Hello, students. Welcome to part 2.
Let's continue with our list of skills. Let's begin with how to add decimals. Our steps for adding decimals include lining up the decimal points. The decimal point of a whole number is after the whole number. So for example, 4 is the same as 4.0. That's a common mistake for a lot of students, is to forget where to line the whole number up as. After you line up the decimals, add normally and keep the decimal in the same location in your answer. So let's look at an example. We have 15.2 plus 4 plus 9.15. So let's put 15.2. Now remember, 4 is like 4.0, so the 4 should be under the 5 because that's a whole number, and put 4.0. And then we have 9.15. The 9 is a whole number, so it needs to be under the 4, and the 0.15 is in the decimal place. And we can add zeros onto these two numbers to make them the same number of decimal places. And now we'll add normally. 0 plus 0 plus 5 is 5. 2 plus 1 is 3. 5 plus 4 is 9, plus 9 more is 18. 1 plus 1 is 2. And then we keep the decimal in the same location, lined up as it was, so that is equal to 28.35, or 28 and 35 hundredths. Now let's talk about how to subtract decimals. To subtract decimals, line up the decimal points. The decimal point of a whole number is after the whole number. Subtract normally and keep the decimal in the same location in your answer. So here's an example. 18.5 minus 3.75. So we have 18.5 and we have 3 wholes, so that goes under the 8. Point, see how our decimal points line up? 7, 5. Now to subtract these, we're going to have to put a 0 after the 5, which is fine because 5 tenths is the same as 50 hundredths. 0 minus 5, do some regrouping, take away 1 whole and make it 10 in the next column. 10 minus 5 is 5. 4 minus 7 also needs regrouped. 14 minus 7 is 7. 7 minus 3 is 4. 1 minus 0 is 1. So this is equal to 14.75. Let's look at the steps for multiplying decimals. Decimals do not need to be lined up to multiply. Multiply normally, as if with whole numbers. Give your answer the same number of decimal places as the total of decimal places in the original problem. So here's an example. 15.25 times 1.5. Multiply normally, ignore the decimal point. So 5 times 5 is 25. 5 times 2 is 10, and 2 more is 12. 5 times 5 is 25, and 1 more is 26. 5 times 1 is 5, and 2 more is 7. Placeholder, 1 times 5 is 5, 1 times 2 is 2, 1 times 5 is 5, 1 times 1 is 1. Add them together. 5 plus 0 is 5, 2 plus 5 is 7, 6 plus 2 is 8, 7 plus 5 is 12, 1 plus 1 is 2. Now, here's the trick. Here's our decimal place. So we have 2 decimal places in the first number. Here's our decimal point. We have 1 decimal place. So we have a total of 3 decimal places. So we need to put a decimal 3 decimal places over in our answer. So 1, 2, 3, which makes 22.875. So this is equal to 22.875. Steps for dividing decimals. Ask yourself, is the decimal the divisor or the dividend? If the decimal is the dividend, divide normally, as with whole numbers, and at the end, bring the decimal straight up. If the decimal is the divisor, use proportional relationships to move the decimal until the divisor no longer contains a decimal. Then divide as with whole numbers, or a decimal in the dividend. So let's look at 2 examples. We have 18.6, which will go in our divide box, divided by 3. Because our divisor does not have a decimal, we just divide normally. So 3 will not go into 1, but 3 will go into 18 6 times, which is 18. There's nothing left over. Bring down your 6. 3 goes into 6 2 times, which is 6. So there's nothing left over. Once we have nothing left over, bring that decimal straight up, so our answer is 6.2. Now let's look at an example where our divisor does have a decimal. So 4 goes in the divide box and 1.25 goes on the outside. Now remember, this is really 4.00. So what we can do is use proportional relationships. Increase the amount by a multiple of 10. So move our decimal point over. One time, which is times 10, and another times, which is times 100. But if we do that to the divisor, we also have to do that to the dividend. So 1 time, 2 times. So instead, we can divide 125 into 400. 125 will go into 400 3 times, which is 375. There will be 25 left over. So we add a decimal and a 0. Bring down the 0. 125 goes into 250 2 times, which is 250. So there's nothing left over. Bring your decimal straight up, so our answer is 3.2. Now let's look at how to add integers. There are many strategies for adding integers, but my preference is to think about positive amounts as having and negative amounts as owing. So if you think about 5 plus 8, which are both positives, if you have $5 and you add $8 or you gain $8, then you have $13. If you owe $5, and you have $8, then you have 3 extra. So when they're different signs, you end up taking the difference of them because one is positive and one's negative. The same is true here. If we have 5 and we owe 8, then we still owe 3 more. So it's negative 3. And then here, if we owe 5 and we owe 8, then we owe 13 altogether. For subtraction of integers, my favorite strategy is to treat subtraction like addition, because the subtract sign means take away, which is a synonym for owing. There is a special rule though. If a problem has subtract a negative number, like negative minus negative 4 or minus negative 10, for example, rewrite the minus negative as a plus sign. And I'll show you an example of what that looks like. So let's treat this one as we have 5 and we owe 8, or we take away 8. If we have 5 and we owe 8, then we're going to have to owe 3 more. Take this one as we owe 5 and we try to take away 8, or we owe 8 more. If we owe 5 and we owe 8, then we owe 13. Now here's that special rule. See how we have a subtract sign and a negative sign? If we have a subtract sign and a negative sign, we can rewrite it as a plus sign. So instead of doing 5 minus negative 8, we can do 5 plus 8. And 5 plus 8 is 13. The same is true here. Instead of doing negative 5 minus negative 8, we can do negative 5 plus 8. And if we owe 5 and we have 8, then we have 3 left over. For multiplying integers, multiply normally, but apply the following integer rules. A positive times a positive is a positive times a negative is a negative, a negative times a positive is a negative, and a negative times a negative is a positive. So positive times positive is positive. That's why we see 5 times 8 is 40. Now 5 times 8 is 40. But a positive times a negative makes a negative. So that's negative 40. 5 times 8 is 40, and a negative times a positive makes a negative. 5 times 8 is 40, but a negative times a negative makes a positive. So do you see how we applied those rules? And last, when you have to divide integers, just divide normally and apply the following integer rules, which are actually the same as multiplication. So instead of thinking positive times positive is positive, a positive divide a positive is a positive. So 15 divided 3 is 5. A positive divide a positive is a positive. Recall our rule for multiplication. A positive times a negative is a negative. So a positive divided by a negative is a negative. And 15 divided 3 is 5. Recall our multiplication rule. Negative times positive is a negative. So negative divide a positive is a negative. And 15 divided 3 is 5. And last, a negative times a negative was a positive, and so is a negative divide a negative. So we get positive 5. So just to review, there are many types of rational numbers, which include fractions, decimals, integers, and whole numbers, and also perfect square roots, which we didn't address in this Math Weekly. All of these can be combined to solve integer operation questions, meaning you can add, subtract, multiply, and divide all of these types.